In this chapter, we're going to look at modelling the basic house shape. Now that we're inside Houdini, we're going to start to build our procedural house using a line. And we can get to the line up here in the shelf tabs. Make sure you're on the Create tab, and then you'll see the line icon here. Hold down Control and left click on the line, and you create a line at the origin. I'm going to hit Escape to come out of the tool, and I'm going to rename this node to House Model, because that's what we're going to make. Now, what I'm going to do is I'm going to build a brick, and I'm going to copy the brick to the points along the curve. So I'm going to use the curve and points as a basis for the house. And when we use the copy tool in Houdini, Houdini generally likes to think that the z-axis is forwards. So I'm going to treat the z-axis as forwards. So I want my wall basically to be facing the z direction, which is this way. So I want the wall to go across the x-axis. So here in the direction, I'm going to set 1 in the x and 0 in the y and 0 in the z. Now, the other thing I want to do is to keep this centered in the world there. So we can move it by adjusting the origin here and changing the offset for that. Now, you'll notice that actually the origin or the offset wants to be half the length because we want it to be centered basically. So it's half the length. Now we've noticed that relationship. Now when you come to building procedural models, you want to look for these kind of relationships, because that way you can automate things about your tool and just simplify the sliders that the user has. Let me demonstrate what I mean. Now in Houdini we use an expression called the ch expression, and it's basically ch to a path. If we hold our cursor over the length here, you'll see it says parameters dist or dist. That's the name that we'll use in the code. Now it's very easy, we don't need to type the code, we can do it automatically. What you do is you select the number here, so this is the number I want to drive this with. I want this number to always be -half of this value. So you select the number that's controlling things, and you right click and say copy parameter. You then select the channel that you want to be driven, right click, and you paste relative reference. Choose paste relative reference. This creates the ch expression, which is ch. It means it's going to read this channel from somewhere else, and this channel here, if we hold our cursor, is called dist. If I click out of there, we'll see that our line jumps all the way over here, because this is taking on the exact value. You can actually click on the word origin and it will switch between what the number is being returned at, and we'll see, look, it is the length as we can adjust it. If you click again, you'll see the code that you typed. Now we wanted this to be -1/2, so we can simply just say times -0.5, like that. And now you'll see that your line jumps to the origin. Now it doesn't matter if I change the length now, because this number is always updating and it's staying at the origin. So we've built in a little bit of this what we call procedural behavior. Just helps automate a lot of the behaviors behind our tool. So now that I've got that, the next thing I want to do, if we have a look at the points, is I'm going to copy a cube to the points to represent my bricks, and there's not enough on there at the minute. So what I'm going to do is use a node called a resample node. So we'll hit tab and type resample. And what resample does, it just creates more points for us. I'm not going to use this method, maximum segment length, but I'm going to use maximum segments instead, because I can be more specific about how many points I get. So remember, I'm going to get a brick for each point. So there's 7 segments, that means there's 8 points. The segment is the line between the points here. Now, just to see how this works, let's create our brick. So to do that, I'm going to hit tab and type box, and this will be our brick model. And so I just want to display that, and I'm going to resize this brick. We're going to make it 0.5 in the x, 0.2 in the y, and 0.25 in the z. That kind of looks like a nice proportion. This z-axis actually is always going to be half the x. I want to keep those proportions the same. So to do that, I'm going to create my ch expression again. So I'm going to select this number, right click, copy parameter. Select this number here, right click, and choose paste relative reference. And then if there's any spurious numbers, just get rid of them. And then we'll times this by 1/2 again. And that just preserves that relationship. So now if I scale the x here with the ladder, we'll see that the z always retains that proportion for us, half in the width, which is good. So what we're going to do is actually copy this to the points of the line, and to do that we use a copy to points node. So hit tab and type copy to points. Oh, what's going on there? Copy to points. There we go. So we'll plug our geometry in on the left, the box or the brick, and we'll plug our curve in on the right. And what you'll see is we've copied a box to each of those points there. Now there's a slight issue here, meaning it doesn't exactly fit. So what we can do to get that to fit is to tell the line to be a specific length. Now if we think about it, we already know the length of an individual brick. It's here, this size x, and we know how many we need by these segments. So if we times this distance by this number of segments, that should be the length of the line that we'll need. We can test that actually. This is 0.5. The segments here is 7. Together that's 3.5 if we multiply them, so let's type 3.5 here. And look, there you go, they're perfectly lined up. So let's build that expression. So if I select the box, we want the size x, so again I'm going to right click, copy parameter, and then in the line here, in the length, I'm going to select the numbers, right click, paste relative reference, which links it to the size. But I also now want to multiply this by the number of segments, which is in the resample node here. So let's select the number of segments, right click, choose copy parameter, and in the line here, after size, in the length here, after the expression there, we can type times, and then right click, paste relative reference. So now we have the box size x multiplied by the number of segments. If we click off, we see that now is returning to 35. So the advantage of that is I can change the size of my brick here, and you'll see that the line gets longer and shorter to accommodate them and make sure they always fit, which is quite useful. The other thing I want to do is to make sure that this sits on the floor. So to do that, I'm going to make a transform node, and I'm just going to drop that in after the brick, and we can type a little expression. Let's just pop this here. We can type a little expression in the transform node. If I click on the information, we can see there's bounding box information here, and I can see the y bounding box is minus 0.1. That's basically where the bottom or lowest most point here is. It's minus 0.1. Well, if I lift that up by plus 0.1, so in other words I add 0.1 to minus 0.1, I'll end up with 0. In other words, that'll move that up to here. And we can do that. We can see that in this translate here. If I put 0.1, we'll see it ends up on the ground there, which is actually the, if we look at this shape here, is the minimum in the y bounding box. And again, we can automate that by using a simple expression. We can type minus $ymin. Now, ymin returns $ymin returns the minimum bounding box, which would be minus 0.1. So let me just get rid of the minus to show that to you. See? Oh, it's not going to return it because it's now adjusted it for us. And if we put the minus in, then it will sit it on the origin for us. And that doesn't matter if we change the height now, because he'll always sit on the floor. And that will extend through to our copies. So again, we're building in sort of automated behaviors here. So the artist only really need to change the size or the height, and it stays in the right position for us. Yep. In a moment, when I copy this around as well, actually, I want to have the back edge here on the axis. So what I'd like to do again with this transform node is move it forwards so it's lined up like that. And we can see here we've moved it forwards in the Z. And let me undo that. And you'll see, because it's halfway through, we actually need to move it halfway from the Z length. And we know the Z length already from the box node here. It's this channel. So we can right click on this channel and do copy parameter, and then we can select the transform here, select the number, right click, and paste relative reference. And then again we can times this by a half, and we'll see that that's moved half that X width, or sorry, Z width forwards for us, and it's sitting on the grid here. Okay, so that looks good for the moment. That'll work a bit later on. So back to the curve here. We've got one line of bricks. What I'd like to do actually is make several lines of bricks going upwards there. So to do that, I can use another copy node. So this copy node I'm going to use is called copy and transform. So let's hit tab and type copy and transform. So C-O-T-R, or C-O-T for copy to transform. There it is, copy and transform. So what this does, it will make a copy and transform it for us. We're not transforming it anywhere. We need to put a value here in the translate y. So let's lift that up. And we can see we have two copies. Each one is half a unit apart. And look, I can make multiple copies here. So I can have a whole load going up. But they're too far apart. They need to be offset, as you can imagine, the height of a brick. So again, we could automate that. We know this should be a height of a brick. If we go to our box object, we know this is the height of the brick. So we can right-click, copy parameter. So in the box, on the Y position here, right-click, copy parameter. And in the copy node, where it's in the translate Y here, let's paste the relative reference. Now if you get any spurious numbers like this, you can just remove those. And there we go. We can see, even if we change the height of our box now, that they're all sitting on top of each other, perfectly lined up. So slowly we're building it up, and you can see how we're building all these relationships in there that we can just change the size of our brick, and everything just works for us. And I'm just using the ch expression, or the channel expression, to link all these parameters, these channels together. So the next thing I want to do, if we go back to our curves here, is, or rather our bricks, is in the typical brick pattern, the bricks, every other row is offset. So what I want to do really is grab every other row and slide them across. Now if I could do this manually, but that would kind of defeat the point of this whole procedural system of Houdini, because we don't know how many curves there would be, and if I select them manually and we change the curves, that's all going to break. So we want to select things in a rule-based kind of way, and that's what Houdini has groups for. So let's make a group. Now there's several nodes to make a group. I'm actually going to use group by range. So if you hit tab, you can type group by range. Here we go. Let's turn this node on. And at the moment you see it's highlighted all of these guys yellow. That's because it's selected all of them. I'm going to rename this group to alternate, because we're going to select every other one. Now it's very easy to do that really with this node. We're selecting here at the range every one of 1. We could select every one of 3. So when I select every one of 3, you'll see we've selected every third one. I actually want every other one, so let's do every one of 2. And there we go, we've selected our alternate, or rather we've put in a group our alternate lines here. Now to make space in your network, you can actually hold down Shift, left click and drag a node, and it'll move that node and everything above it. And then again, if you hold Control and left click and drag, it will move that node and everything below. So using those two keys, you can quickly make some space. So let's make some space after the alternate here, after the this group. I'm now going to add a transform node. Let's turn that on. And if you hit Enter with that node selected, and your cursor over the 3D view, when you hit Enter, you'll see the handle. And look, I can obviously move all the points with the transform here, all the lines. Now, all Houdini's nodes, or most of Houdini's nodes, have this group section, which means this node will only affect the things in a group. In other words, our procedural selection. And we can find that in the drop down here. There's my alternate group. As soon as I select that, you'll see that the transform's only affecting those lines, which is every other line. If we turn back on our copy to points, we can see we're actually directly moving the bricks. Now, the way to have this done, we really want the bricks lined up to be half, again, this long axis, the x-axis. And again, we know we can link that with the expression. So I want to link this number with, on the transform node here, with half the x length. So let's go back to our box, select the x length here, right click, copy parameter. Let's go back to our transform node, select that whole translate x here, right click, paste relative reference. Let's get rid of any dodgy numbers. And remember, we want to multiply this by a half, and there we go, we're offset by half the length of a brick. If I now change my brick length, we'll see the lines and the bricks always stay lined up. And then with this copy node, we can make more or less repeats of that. Excellent, we slowly get there building our brick wall. So the next thing I want to do is to copy this around 4 times to make the 4 walls of the building. So to do that again, I'm going to use another copy and transform node. Let's just drop that in to here. I'm going to leave the display of the copy to point so I can see all the bricks there. Now on the copy to transform here, we're going to type 90 degrees in the Y here. So we've rotated one copy 90 degrees. In fact, if I do 3, 4, we'll get each copy going 90 degrees around. Now you'll notice there's a slight problem here. Well, there's a couple of problems. First of all, it's not in the right place. We can fix that actually by before this copy node, we can add another transform in. So let's add another transform node in. And if I move this back in Z, you'll see that they slowly can come into position. So we can offset this guy by a certain amount, and we can get that to work. But we don't know what that is at the moment, and before we go there, we want to see that looking at it, some of these aren't lined up correctly. Now the reason the bricks aren't lined up correctly is because this copy to points node uses normals or the n attribute to orientate our bricks. And if we go back to sort of the original resample here, and if I turn on the normal display, you'll see there aren't any normals. If I look on the information, you'll see there's no n attribute. Now remember I said Houdini likes to think things are facing forwards down the Z. So I'm going to create a normal attribute facing down the Z. And if you look at my box here, it's built that way. So it will treat that Z as facing forwards, and it will orientate along the curve in this way. So let's create that normal attribute. So for that I'm going to use an attribute create. Obviously you can use your favorite method to create an attribute. But let me turn on the attribute create here. I'm going to change that to capital N. Going to make sure it's a size of 3 because it's a vector, and we want it facing down the Z here, so it's 0 in the X, 0 in the Y, and 1 in the Z. As soon as I do that, we'll see the normals are facing down the Z axis here. If we look at our copy, we'll see that all the normals now are radiating towards the center, and if we look at our copy to points, let's turn the normals off, we'll see all of our bricks are now orientated quite correctly. Now this guy here, this transform, remember we were moving that in and out. We can see we kind of want somewhere around here. Now if you think about it really, it's pretty much half the length of this wall. And we know the length of the wall actually, that's from this line node here, this length. So I'm actually going to copy this parameter for the length here, so right click, copy parameter, and down in this transform, we're going to select this number here, right click, paste relative reference, and let's get rid of those numbers. And it's gone the wrong way, so we need to times this by minus 0.5. Remember we wanted a half, and we want it to flip the other way. Now we're almost there. It needs to come out a little bit further. The reason it needs to come out a little bit further is if I just plug in, let's just move these guys over. If I just plug in the resample on its own, or rather the normal on its own into the copy to points. Let's just turn on the curve and template the points. What you'll see is actually we're even though we're a length short, we're measuring the length of the curve, we've actually got a whole length of one of these boxes extra or bricks on the end. So we've not got to consider that when we're doing the transform, so it's a little bit more than what we had anticipated. So it's a little bit more than half of that way across. So what it is, it's about 3/4 of the X here. So what I'm going to do is grab the X axis here, let's do copy parameter, and in this transform we're going to minus again, so let's just put a bracket in, and then we'll paste our relative reference of that X, and we'll times this by 3/4, which almost gets us there. You'll notice we're kind of a quarter missing. So what I want to do is, if we go back to our brick model here, let's go back to where we had a single line. What I really what I want to do is offset it by a quarter of its length here, this way. So to do that, I'm going to manipulate this transform again. So in the X here, we want to slide it across by a quarter. So here I'm going to select this X and we'll do copy parameter, and then down here in the transform underneath it, we'll select the X parameter, right click, paste relative reference, and then we'll times this by 0.25. Oh, we want that to be minus 0.25. There we go. Let's plug everything else back in. And you'll see that's offset it by the correct amount, by 0.125, or a quarter of the brick size there. And that gets the corners to match up for us. Now if we change the size of the brick now, you'll see that because we've used all the same proportions, it's filling out the gaps and keeping all our bricks together. And we can change the height of the bricks here, or the building with that one, with the this copy node. And we can also change the number of segments and change the number of bricks that we've got there as well, which also changes the size of the bricks. So we've built in all that behavior so far into our little procedural house system here. So I'm going to finish that off by adding a little null in here, and I'm going to call this bricks out. We often put nulls with capital letters. The capital letters means they're going to show up at the top of our tree view should we want to use that. So we've built in some interesting behaviors and fairly automated this, and we've got some nice controls, meaning we can just change the size of the brick or the number of segments and get sort of different shape buildings and stuff, and all the bricks lay out as we want them to. So in the next section, what I'm going to do is make a rough template for the building and cut the roof and the doors. So let's have a look at that.